Hey guys, Mr. Yisley here. So we're on to lesson number 8 and chapter 2b, which is all about solving linear inequalities. And in lesson number 8, we're going to solve some linear inequalities that are division examples. And so we've got 3 examples here we're going to go through. Before we do that, just a reminder, our approach is really 4 steps when we're dealing with multiplication or division. First step, find your variable, figure out what's being done to it. So if it's being multiplied or divided, or in other cases could be added or subtracted. Then we need to reverse that operation by undoing it. Now, where it's a little different with multiplication and division is we need to figure out, are we multiplying or dividing by a negative number? If we are, that causes that inequality symbol to reverse the opposite direction, and we need to do that in the third step. And then fourth step, we solve that inequality to get it simplified all the way down. All right, so let's take a look at example A. Example A says negative 7y is less than or equal to negative 35. Well, first thing I need to do, find my variable. Well, I see I have a y right here, right? And what is happening with this y? Well, there's a negative 7 out in front, so it has a coefficient of negative 7. Well, remember, coefficients are always multiplying those variables. So the y is being multiplied by negative 7. So if I go in to make my to-do to undo list, they were multiplying y by negative 7. Well, the inverse operation of multiplying by negative 7 is to divide by negative 7. So we just, instead of multiplication, we're dividing, and the number itself stays the same, both if it's positive or negative. And in this case, it was a negative 7, so we're going to divide by negative 7. So there are our steps to solve, so let's go in and do that. So underneath where they were multiplying this, I'm going to draw my division sign, which I'm going to use as a fraction, and I'm going to say negative 7. And then whatever I do to one side, I also have to do to the other. So division shown through subtraction or through a fraction, and then negative 7. All right, well, now let's go in and solve that. So again, anytime we are dividing a number or something by the same number we're multiplying by, negative 7 divided by negative 7 is just 1. So really this just cancels out, and all I'm left with is my variable right there of y. So I'm going to bring that down. Now I need to check my inequality symbol anytime I'm multiplying or dividing an inequality, and we are dividing by a negative number, which means that this inequality symbol is going to flip around. So I'm going to, instead of have less than or equal to, it's now going to become greater than or equal to. And then I need to do the right side, which says negative 35 divided by negative 7. Let's start with the numbers. 35 divided by 7 is 5. And then a negative divided by a negative is a positive. A bad thing happening to a bad guy is good. So I ended up with y is greater than or equal to 5. All right, well now we need to go to our number line and we need to label this. So we'll start with the number 5 here in the middle. I'm going to count by 2s, skipping every other dash. So 6, 7, 8, 9. That's enough moving that direction. So now let's do some the other way. So 4, 3, 2, 1. There we go. So I've got my number line labeled, easy to follow. So then got to choose a number to the left of 5 and then a number to the right and plug them in to see which one's true. So starting with the number to the left, I choose 3. So I've got 3 is greater than or equal to 5. So I plugged the 3 in for the y. Well, is 3 equal to 5? No, it's not. Is it greater than 5? No, 3 is not greater than 5, so this is false. So that should mean my arrow is moving to the right, but let's check a number to the right to make sure. So I'm going to choose 7. Plug that in. 7 is greater than or equal to 5. Well, 7 is not equal to 5, but it is greater than 5. So this is true. All right, and then we need to go in and we need to actually graph it. So we start with the number 5 and we draw our circle. So circle right here on number 5. Then we look, is there any portion of an equals to sign? Yes, there is. So it is a filled in circle. And then we need to draw our arrow towards the true side, which was the right side of the number line. There we go. All right. Well, I'd encourage you to try example B on your own, then check your answer with mine. So example B says 9m is greater than 63. So 9 times m is greater than 63. So first step, find our variable. It's right here on the left side, my m. What's happening with it? Well, it's got that 9 directly out in front. No symbols of any operations in between, so that means it is multiplication. So if I'm going to write my to-do to undo list, I would say, hey, they are multiplying by 9, which means for me to undo that, I need to use the inverse operation of multiplication, which is division. So I'm going to divide, and I'm going to divide by the number they gave me, which was 9. So there is my step to solve. So now I need to go in and solve it. So to show division, I'm going to use a fraction symbol, and I'm going to put it over 9. And I'm going to do the same thing to the other side, because whatever I do to one side of the inequality, I have to do to the other to keep it in balance. So there is my steps to solve. So now I need to go in and do that. Well, 9 divided by 9 is 1, so really these 9s just cancel, and all I'm left with is the variable of m. Then I need to check my inequality symbol. Well, I am dividing, but I'm dividing by a positive number. And anytime I divide by a positive number, it does not change the inequality symbol. So it's going to come down as is, so m is greater than, and then I have to do 63 divided by 9, which is 7. So I ended up with m is greater than 7. So last few steps that I need to do now. First thing, label my number line. So I'm going to start with the number 7 here. I'm going to count by 2s, skipping every other dash. So 8, 9, 10, 11. Move in the other directions. 6, 5, 4, 3. And there we go. We're labeled, easy to follow. So then choose a number to the left of 7. I choose 5. Plug it in for m. So 5 is greater than 7. Is that true? No, 5 is not greater than 7, so that's false. So it should be an arrow moving to the right of 7, but let's check. I'm going to choose the number 9. 9 is greater than 7. Is that true? 9 is greater than 7, so this is true. So now we need to go back to the number 7, and we need to draw our circle. So here at 7, draw my circle. Is there any portion of an equals to sign? No, there's not, so it's not a filled-in circle. So that's a starting point, but it's not a solution to the inequality. Right? And then I need to draw my arrow moving towards the true side, which we figured out was the right side of the number line. So everything moving to the right of 7 is a solution to the inequality. All right, well, if you'll flip your note packet over to the next page, we've got one more example to go through, and I'm going to encourage you to try this one on your own, then check your answer with mine. All right, well, example C says negative 2r is greater than or equal to negative 22. Right, well, I see I have a variable of r here with a negative 2 out in front. So it has a coefficient of negative 2, which again, if that number is directly next to the variable and there is no sign in between them, right? Not a sign in front of them, but a sign in between them, that means multiplication. So the r is being multiplied by negative 2. So if I create my to-do to undo list, I'd say, hey, they were multiplying by negative 2. Well, I need to undo that, so I need to do the opposite of multiplication, which is division. And instead of multiplying, I'm dividing by negative 2. So there is my step to solve. So I'm going to go in and show that. So again, using the fraction symbol underneath the negative 2r, I'm going to put that to show division, and then my negative 2 underneath. Well, whatever I do to one side of the inequality, I also have to do to the other. So underneath negative 22, fraction symbol to show division, then negative 2. All right, well, as we learned about before, anytime we divide by the same number that we were multiplying by, that just causes those to cancel out because negative 2 divided by negative 2 is just 1. So all we're left with on the left side is the variable of r. Then we need to look at our inequality symbol anytime we're multiplying or dividing and decide, does it flip or does it not? So I've got greater than or equal to. Well, we are dividing, but we are dividing by a negative number. So that means this inequality symbol has to reverse the other direction. So instead of greater than or equal to, it becomes less than or equal to. And then we need to do the division over here. So I've got negative 22 divided by negative 2. Let's start with the numbers. 22 divided by 2 is 11. And then a negative divided by a negative is a positive. Remember, bad thing happening to a bad guy is good. We like when that happens. So I ended up with r is less than or equal to 11. So now let's go ahead and get this thing started on graphing. So we'll start with the number 11 here in the middle. I'm going to count by 2, skipping every other dash. So we're going to say that's 12, 13, 14, 15. That's enough numbers to the right. Let's choose some to the left. So 10, 9, 8, 7. So there we go. We've got our number line labeled, easy to follow. So then I need to choose a number to the left of 11. I choose 9, and I'm going to plug it in to see if it makes it true. So 9 is less than or equal to 11. Well, 9 is not equal to 11, but it is less than 11. So this is true. But let's just check a number to the right and make sure that that is also true, not true. So number to the right of 11 is 13. Let's plug that in. So 13 is less than or equal to 11. Right? Well, 13 is definitely not equal to 11, but it's also not less than 11. So this is false. So everything moving to the right of 11 should be false. Everything moving to the left should be true. So we now know which way to draw our arrow. So again, back to the number 11, draw my circle because that's my starting point. Look for, is there any portion of an equals to sign? Yes, there is. So this is a filled in circle because 11 is a solution as well. Right? And then last part, draw my arrow moving towards the true side of the number line, which is the left side. All right, well that is how we solve when we have to use division to solve a linear inequality. Again, just like with multiplication, make sure that you pay attention to if you are multiplying or dividing by a negative number, that causes the inequality symbol to flip the other direction. If you have any additional questions, please let me know, but otherwise you should have what you need to continue on in the chapter.